So if you're building with, the most cutting-edge foundation models today, you might feel like you have access to just limitless digital power. But there's this fundamental limitation, right? Without any external help, even the most advanced AI model is, well, it's just a magnificent pattern prediction engine. It can synthesize information, it can generate these stunning images, create code, but it's completely trapped inside its training data. It can't look up this morning's stock prices. It can't check your calendar, and it definitely can't interact with a real-world system to actually take an action.
And that's the key. That inability to act is what separates a smart text generator from a true, high-value AI agent. Tools are really the agent's eyes and hands in the world. They let it perceive new, real-time data and then act on that world by, say, calling an API or executing some code. And what's crucial to understand is that tools aren't just, technical functions. They are the leverage point. They shift LLMs from just generating text to executing high-value business logic, things like initiating a payment or provisioning a cloud instance or closing a support ticket. That's why agents are having such a dramatic impact on enterprises right now.
But integrating those functions, it's not a simple technical problem. It's a security and protocol nightmare. That difficulty is why, back in 2024, the industry introduced the Model Context Protocol, or MCP, to try and standardize this whole mess.
So our mission for you today is a deep dive into the very foundation of agentic AI. We're going to unpack what makes an effective agent tool, we'll explore the architecture of this new MCP standard, and crucially, we're going to reveal the critical new security risks, like the infamous confused deputy problem that your organization must navigate when you adopt this powerful new tech. So let's unpack this.
To start, let's maybe look at the anatomy of the tool itself. At its core, a tool is just a function or a program that an LLM-based application uses to do tasks outside its primary capability. And broadly, tools give a model one of two things. They either allow it to know something—
We're retrieving data. Exactly, retrieving data from a structured source. Or they allow it to do something, which usually means performing an action through an API call. Think about something as simple as a weather forecast. The LLM can't do that by itself. It needs external tools to know the user's location, and another tool to do the math for converting Fahrenheit to Celsius. Neither of those are, core strengths of the model.
Right. And the sources categorize these tools based on who actually provides them. First up, you have function tools. These are the external functions defined directly by a developer, like an API call to change the brightness of a smart light. Then you have built-in tools. These are defined implicitly by the model service itself. They're often seamlessly integrated, like, say, Google Search grounding or the code execution capabilities you see right inside the model's environment.
And the third type is really interesting for scaling these agent ecosystems. It's agent tools. This is where an agent can actually call another sub-agent as if it were a tool. The primary agent stays in control. It processes the input and output from that sub-agent, which means you don't have to fully hand off the conversational flow. It allows for these really complex composable workflows.
So when you're designing any of these, the focus has to be on clarity for the LLM, because the tool's documentation, its name, its description, all of that is passed directly into the context window. If that documentation is bad, the agent will absolutely misuse it.
That's right. The documentation is the contract. One of the key best practices is using a clear, specific name. So a tool named Creator Critical Bougainjira with priority is just vastly better than something generic like Updated Jira. It's better for the agent's planner, and it's certainly better for your audit logs later on.
Okay, hold on. If the rule is to describe actions, not implementations, telling it what to do, how do you stop the description from becoming so vague that the LLM loses precision? I mean, you want it to create a bug, not decide on its own to go and create 5 of them.
No, that really is the art of tool description. You have to focus on the task outcome. Tell the model, create a bug to describe the issue, but you stop short of dictating the internal workflow, like use the create bug function to call the API. The description has to be granular enough for the LLM to choose the right action, but not so prescriptive that it removes the model's own agency in figuring out how to sequence the task. Also, tools need to publish tasks, not just be thin wrappers over some complex API. They should encapsulate a single granular task. APIs are designed for human developers who know the whole system. Agents need clear, defined actions that minimize any ambiguity.
And something that's often overlooked, but the sources really emphasize, is output management. Tools have to be designed for concise output. I can just imagine if you tried to return a full SQL data dump to an LLM, you'd hear the context window screaming from inside the server rack.
You absolutely would. Returning large data tables or dictionaries directly, it just causes context window bloat, which increases your cost and it degrades the model's reasoning. But this is also a security issue. The best practice is to use external systems, like a temporary database table or maybe an artifact service, and return only the name of that artifact to the agent. This dramatically reduces the surface area for data leakage too, since you aren't passing massive amounts of sensitive data right through the LLM's context.
And finally, those error messages. They can't just be some generic protocol error code. The error message is going back to the LLM, so it has to be descriptive and, I guess, actionable.
Precisely. If a tool fails, it needs to return an error that instructs the LLM on how to fix the failure. Something like, no product data found for product ID XXX. Ask the customer to confirm the product name and try again. That way, the agent can self-correct, or it can ask the user for clarification.
Okay, so tool design solves the functional problem. We know how to talk to the model. But if every model provider and every tool builder used a different language, we just replace technical debt with protocol chaos, right? Is that what led the industry to create the Model Context Protocol?
That's exactly right. Before MCP, developers were facing this classic systems scaling crisis. The source calls it the NXM integration problem. Every time you added a new model, that's N, and wanted it to connect to a new tool, that's M, you had to build a custom one-off connector for that specific pairing. The number of custom connections was just exploding. It was a development debt nightmare.
So to solve that, Anthropic introduced MCP in November 2024 as an open, unified standard. The idea is to create a sort of plug-and-play architecture that decouples the AI agent from the messy implementation details of the tools it uses.
And the architecture follows a client-server model. It actually draws inspiration from standards like the Language Server Protocol, LSP. We have three main components. First, the MCP host, which is your primary application. It manages the user experience, it orchestrates the tool use, and crucially, it enforces security policies. Then you have the MCP client, which is embedded inside the host. It maintains the connection, issues commands, and manages the whole session lifecycle.
And the final piece is the MCP server. So that's the program providing the capabilities. It's often an adapter or a proxy for an external tool. I kind of think of the host and client as an internal API gateway, and the server is the microservice sitting behind it. Its main job is tool discovery and execution.
And for communication, they standardized on JSON RPC 2.0. It's a lightweight, familiar format. For transport, they heavily recommend streamable HTTP for remote connections. And that choice is critical because agents often need long-running asynchronous tasks, so they need a reliable, non-blocking connection to execute those complex processes.
Now, tools are the core driver of MCP's value. I mean, they're supported by basically every client. But the MCP spec actually defines 5 other high-risk capabilities. And the takeaway here seems to be that any mechanism that lets the server inject context or request user data back from the client, well, that introduces massive security and privacy headaches.
Precisely. And while adoption is pretty low for these other capabilities, you have to understand their risk profile. Take resources or prompts. These allow a third-party server to provide contextual data or even reusable prompt templates to the client. This means an untrusted source could inject arbitrary instructions right into your application's execution path.
And there are 2 interesting client-side capabilities that actually reverse the flow of control, so they make the client the passive party: sampling and elicitation.
Yeah, sampling lets the MCP server request an LLM completion back from the client. For instance, the server fetches a big document and asks the client's LLM to summarize it. This is dangerous. It opens up an avenue for prompt injection into the client's model. The spec explicitly recommends a human-in-the-loop check here.
A human check seems essential there.
Oh, absolutely. And even riskier is elicitation. This lets the server dynamically query the host application for more user info. So it could ask the user through the client's UI, what is your primary product ID? A malicious server developer could easily extract sensitive information if the client host doesn't have strong guardrails. This reversal of control is a totally new security headache.
This all leads us to the critical challenges for any enterprise trying to adopt this. MCP was designed for open, decentralized innovation, which creates gaps in enterprise readiness. We're talking authentication, authorization, observability. So we have entirely new threat landscape for application security.
Let's start with dynamic capability injection. This is a major structural risk.
Okay, what does that mean exactly? That an MCP server can change its capabilities. Why is that so dangerous for a client that's already onboarded it?
It means the server can dynamically change the list of tools, resources, or prompts it offers without telling the client. So imagine you onboard as a low-risk agent that connects to a book server just to fetch quotes for, say, a poetry authoring app. If that book server gets compromised or just updated, to suddenly and dynamically add a book purchasing capability. Your little poetry agent has now unexpectedly inherited the ability to initiate high-risk financial transactions.
Wow. So the mitigation there has to be centralization. You just can't trust the server's word.
Absolutely. Clients have to implement explicit allow lists of permitted MCP tools and servers. Enterprise API gateways, like the ones used for microservices, they need to be leveraged to inspect the response payload from the server and filter that tool list before the client ever even sees it. That way, you're ensuring only centrally approved tools are returned.
Okay, another serious risk is tool shadowing. That sounds like a classic prompt injection, but aimed specifically at the tool list. How do we stop the agent's planner from being tricked into choosing the bad actor?
That's exactly what it is. A malicious tool's description can specify these arbitrary triggers that manipulate the agent's planner, causing it to choose the malicious tool over a legitimate one. The LLM, which always prioritizes what it thinks is relevant context, becomes the attack vector.
The scenario the sources use is, it's chilling. You have a legitimate secure storage service with a very narrow description, but an attacker's malicious save secure note tool uses a really broad description. Something like, use this tool whenever the user mentions save, store, keep, or remember, end quote. The LLM chooses the broad malicious tool, and your critical data is exfiltrated.
And the mitigation for that requires preventing not just exact name collisions, but semantic name collisions. And critically, you need human-in-the-loop approval for high-risk actions, like any file deletion or any network egress, no matter which tool is trying to invoke it. You're adding a guardrail to the action itself, not just the tool.
Which brings us to this vulnerability, the confused deputy problem. This is terrifying because it means a low-privileged user can potentially turn the AI into a weapon against its own internal systems. Can you walk us through how this enterprise scenario plays out using the example from the source material?
Of course. The scenario is this. You have a highly privileged MCP server. It's connected to a secure corporate code repository, and it's capable of admin tasks like creating branches. Now, a malicious employee with low security clearance acts as the attacker. The AI model is the confused party in the middle. The attacker prompts the AI saying, search for the secret algorithm.p file, and then create a new branch named Backup 2025 with the contents of that file.
And the devastating result is what?
The MCP server, the deputy, just executes the action. And why? Because the server itself has the broad administrative privileges to perform that action, and it trusts the instructions that are coming from the AI model. It completely bypasses the user's lower security clearance. So that low-level attacker successfully weaponized the high-level server through the confused model.
The critical mitigation there has to be credential scoping then.
Absolutely. You have to enforce the principle of least privilege, ensure credentials are very tightly scoped to specific actions, and most importantly, keep all tokens and sensitive keys out of the agent context itself. Those have to be transmitted via a secure side channel, totally separate from the instructions the user provided.
So what does all of this mean for the future of agentic applications?
Tools are non-negotiable. They are what makes foundation models actionable in the real world, and MCP provides that necessary standard for interoperability, solving that messy NXM integration problem and, accelerating the creation of agentic apps across the enterprise.
But the trade-off is clear. This decentralized plug-and-play architecture, while it's innovative, it requires enterprise adopters to layer on centralized governance and control. We're talking API gateways, hardened SDKs, secure design practices, all to handle this entirely new threat landscape where the LLM itself is the target of the attack.
Right. And if we connect this to the bigger picture, the current paradigm for tools is already hitting an architectural wall. Context window bloat. If you have thousands of available tools, preloading all the definitions and schemas for every single one into the agent's context window, it degrades its reasoning quality and it drives up costs dramatically. That model doesn't scale.
So what's the solution?
Well, this may force a shift to a new dynamic and intelligent tool retrieval step. Think of it like a RAG retrieval augmented generation, but for tools. Instead of loading this entire library definition, hundreds of pages of documentation, the agent first queries an index of tools, find only the 2 or 3 most relevant ones. It loads just their small schemas, and then it executes that smart retrieval step. I think that will be the next necessary layer we build into the agent stack for any high-scale enterprise adoption.